Get ready to blast off into the incredible world of brain-computer interfaces. Neurocareers doing the impossible is taking you on a journey to meet the fearless pioneers pushing the boundaries of what's possible. In this special series, we'll be shining a spotlight on the nominees and winners of the International BCI Award, one of the biggest and most prestigious awards in the BCI world. You'll hear from BCI professionals as they share their revolutionary work and get a behind the scenes sneak peek at what it takes to be a winner. So, buckle up, grab a snack, and get ready to be amazed as we explore the impossible becoming a reality in the world of BCIs. But before we blast off, I want to give a big thanks to the co-host of this BCI Award edition on our podcast, Dr. Christoph Guger and GTech Medical Engineering. When I was a faculty member at the University of Cincinnati and Cincinnati Children's Hospital Medical Center, my team and I did some pretty amazing stuff for patients needing epilepsy surgery. We would put special sensors, also called grids, directly on their brain to prepare for surgery and create maps of their brain in a much faster and safer way than is usually done. It's called high gamma mapping, and it lets us figure out in just a few minutes the essential parts of the brain that need to be spared during surgery. Can you imagine? You can create a map of language, motor, and even math processing in no time. It was the first time this innovative technology was used at Cincinnati Children's Hospital Medical Center. When I moved to Florida, I established the first functional brain mapping and BCI program at Florida Hospital. I continued to use high gamma mapping to help epilepsy patients avoid losing their ability to speak or move after surgery. But even cooler than that, I created brain-computer interface studies that let patients control things with their brain in real time. Our patients could even spell words with incredible speed by just using their brains. No hands involved. I also discovered that brain-computer interfaces could help patients move their chronically impaired hands or legs years after a stroke when not much else could help them. So, I started working with the faculty from Advent Health University to help these patients restore their ability to use their hands. I received special training for it, and it's still mind blowing how cool it is. My favorite part of what I do is teaching. At my established Institute of Neuro Approaches, I've integrated all my experience and knowledge into a unique course on brain-computer interfaces. With graduate neurobiology students, we started with theory, and then I gave them the BCI equipment so they could have hands-on experience working with BCIs. It significantly improved the way students learn, and they absolutely love this practical part of learning how to use neurotechnology. And all of this was made possible thanks to GTech's awesome brain-computer interface technology. They have everything from high-tech up to 1024-channel EEG systems to wearables, tools for neurorehabilitation, such as the medical grade system recoveries and educational kits with unicorn hybrid plug for learning how to work with BCI technology. But the most important part is their support and care. I have enjoyed working and collaborating with Dr. Christoph Guger and GTEC employees for over 15 years, and I hope for many more successful years ahead. So, if you are interested in GTEC's brain computer interfaces and neurotechnologies, check out their website at gtech.at. It's worth it. And keep in mind, I do not receive any financial support from GTEC and share my honest opinion supported by many years of experience working with their equipment. Dear listeners, welcome to Neurocareers, the podcast that brings you the latest insights and innovations about the exciting careers in neuroscience and neurotechnologies. I'm so excited to present today a new episode of our BCI Award podcast series. In this episode, we have the pleasure of speaking with Dr. Victoria Peterson, a leading researcher in the field of BCIs, whose project was nominated for the prestigious International BCI Award in 2021. Her team's project is titled Improving Cross-Session BCI Decoding via a retraining-free optimal transport transfer learning approach. And it promises to improve the way we approach BCI decoding. With BCIs, we are able to connect the human brain directly to a computer, allowing us to control devices. But with new technology comes new challenges. And decoding the signals from the brain in a reliable and consistent way has been a persistent hurdle for researchers. That's where Victoria's team comes in with their approach to transfer learning that doesn't require extensive retraining between sessions. In this episode, we will explore the science behind this approach and the potential impact it could have on the future of BCIs. So sit back, relax, and get ready to learn from one of the brightest minds in the field. It's time for Neurocareers. Welcome, Victoria. It's such a pleasure to have you today on our podcast.
Thank you, Milena. Thank you for having me. I'm super happy to be here, to be honest.
Yeah, it's my great, great, great pleasure. So thank you. And can you please introduce yourself and tell our listeners where you are joining us from and maybe some interesting fact or story about the place where you are working and where you live?
Yeah, so I am from Argentina and I'm currently, my lab is located in the city that is called Santa Fe. Maybe everyone knows where Buenos Aires is, but most probably you don't know where Santa Fe is. So I'm just gonna, give you like an idea that Santa Fe is like 500 kilometers towards the north in Argentina. And that this place is important and in the matter of like a scientific and university like environment that we have. So something that I really like about Santa Fe that it's a capital of one of the provinces, but also is like here we have like great scientific like and like a pole in which we have the university so close, a lot of like different institutes, different like areas of science and technology. So this is something important. And also here in Santa Fe, actually, my affiliation is CONICET, that stands from the Consejo Nacional de Investigaciones Científicas y Técnicas. That means the National Council of Scientific and Technologies Research. That's the meaning of that. That is a big entity that englobes all the researchers in Argentina. And some important fact is that the first CONICET Institute was actually generated here in Santa Fe. So that's why it's important also here from the scientific point. But there is a fun fact. So in Santa Fe, something everybody likes to do is to drink beers. Because I mean, to be honest, you can buy a glass of beer much, cheaper than a glass of water. So I know that that is important for like a lot of people. So that's why I always say,
Yes, that's really fun. And what is the weather like right now in Argentina? So right now we have March 22nd.
so we actually as yesterday started the fall, right? But we were having some crazy summer day here, like 40 degrees. That this is not really common from like being in March. So people like we were all a little bit like a mad of having still summer because in Argentina like the like the packing school like classes the semester starts in March. It's not like other places. So here we go from March to December. So this idea of having it 40 degrees outside and also going to teach, give a course or take a course. That was something that a lot of people was like, oh my god, I can't do this because mosquitoes all over the places. But now it's raining, so everybody is happy now because raining, it's nice with rain. I'm writing a grant, so it's super like inspiring. Also, when I hear the rain, over my head. So yeah, at the moment it's raining.
Yes, beautiful, beautiful. And it's also interesting how schools semesters start differently in different places. Very good. So, can you tell our listeners about your background that brought you to doing this project that was nominated for BCI Award? And you and I talked a little bit before we started the recording that actually your choice of career was somewhat unusual, yes, to the people around you. So, can you tell about that?
Yeah, sure. This is a funny story that I always like to joke about because but it's also I think that it's also kind of inspiring in that I am a woman, right? I have 33 years old. It's not that I am in my middle age. And I decided to study biomedical engineering. So I am a bioengineer. And here in Argentina, now you have several like programs that you can be in different places all over Argentina. But at that moment, there were few. And I studied near the city where I was born, the city of the where my faculty is located is Oro Verde. It's a small university city. And biomedical engineer career was something that when I was telling everybody that I was arguing, I was eager to follow that program, everybody was like looking at me and saying, what the biomedical engineer do? It's like, what are you gonna do? It's like I don't get it. Are you a biotechnologist? No, 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 no. I am a biomedical engineer. So this is something I have to always explain. And yeah, so I decided to study that because at that moment you don't really know. It's because you like math, you like physics, you like that type of science. But now I have realized that that is the reason why I decided to pursue the, the, the this beautiful combination that is the biomedical engineer that is medicine and engineer, or I would say, of course, the engineer applied towards improving medicine, right? That's what we do in any sense in the different fields in which you're working on. So the reason why I decided to study biomedical engineer, now I realize that could be because my eldest brother, so he was born with some disability, like for hearing, so he lives and now he has a beautiful, I would say, like a normal life. Although the severe, like disability he has from like him being able to listen to. So it's not death, it's something kind of. But the device, the hearing eye device, I mean, that I realized that that is a biomedical like device that is improving the quality of life of someone. This someone is particularly my brother, right? But this is what we do biomedical engineering. Like, and that is what I want to do. And that's the reason why BCI is what I like to do. Because I can apply engineering, like a lot of mathematical stuff or like computational stuff. But my aim when I have the chance to understand what a BCI was and work in a BCI area was is, and I really want this to come true, is like I want to help people and that the technologies we build can be used and I dream them to be used like to improve the quality of life of someone. So yeah, the thing is that for Wally, this is also a funny fact that I always like to say is that here I feel like a weirdo. It's like I am a biomedical engineer. There's a few people that sadly is that following or pursuing that career. But when I had a chance to be like in other countries during my PhD study or my postdoc study, I realized that a biomedical engineer is a program that a lot of people follows. And I was like, okay, I am not weird. And I was like, this was the first time I didn't have to explain what was a biomedical engineer, application or what a biomedical engineer work in. So I was like, okay, I always thought that was a unique case, but it's not outside. So I think this is more or less the story and how I decided to study biomedical engineering.
Yes, that's a very inspiring story. I also mentioned today when you and I talked, we had a conversation with Eva Esteban from Open BCI, and she was saying very similar things. That when she made a decision that she will go into engineering and computer science, people were saying that, are you crazy, to go to this type of field? Nevertheless, so she made that decision and she persevered. So my question is, what maybe character trait helped you in spite of whatever people were saying? Yes, that you are that's you're a weirdo. Yes, doing this, that's weird. What helped you to persevere and still do what you wanted to do?
Yeah, this is something there was one moment, and because someone actually asked me, because I am a woman, I am a scientist, I work in the STEAM areas, and that is something that a lot of people like it's asking me, and there was a moment in which I said to myself, wait, stop, think about it. How did you do it? Like, literally. And I have to say that I am one of those that has a lot of like in their life because my parents in the first time they never told me that this is something that you cannot do. Actually, that's something important because I did have the support for like pursuing any program that I wanted. And when I decided to be a biomedical engineer, they were that's great. I'm so happy for you. And I think that that's the first thing that I was lucky already. The second one is that, and this is something I borrowed from a colleague of mine, is that we ended up being we are like survivors in a way, because there are a lot of barriers and limits that happens, like these comments that people can do, these are situations that we can live that is all the time, we are all the time without consciously knowing that, but we are all the time asking ourselves, I am in the right place. I am in the correct decision. That is the correct decision. Should I follow it? Should I meet, this environment that can be tough? And yeah, here we are. So secondly, I think we are like a chameleon that we can a little bit like maybe adjust to the environment. And that is something that is like a way of being survivor. That's what I'm saying. And although I always knew that I was feeling the weirdo and that for my friends, I am the nerdy one that is doing all this, I never cared, to be honest. I think that the passion has been always, my motto, my engine, literally, to follow what I wanted to do. And that is, for me, means being lucky and means being a survivor because we survived through all those comments that can be really harmful.
Yes, that's true, and I'm so happy you did. And I'm very curious about what did you want to become when you were at school in elementary, when you were growing up? Yes. Did you have already at that time some interest in engineering and math and what did you want to become?
Yeah, when I was in elementary school, I wanted to be an architecture. I don't know if that is the correct thing. Yeah. So I wanted to be that. And there was a moment, and this is I feel a little bit shame about this. Because there was a moment that I said, oh, I want to be a model, walking in the catwalk and all this kind of stuff. And now now that I think about all this, I remember the moment at which I decided to be an engineer. But now I see that I want to be a model too, by an engineer model. I want to be, like a scientific model. So I have these dreams, so like being someone that opens and walk in some path, because it's something that I really want, like as a scientist, is that, of course, my research be the best as I can do, of course, but also to show to others that we can do this. So if you want to pursue like a STEM career, this is also your path. So that's the thing. But I don't remember yeah, this is maybe the question that, but I don't remember being in elementary school and dreaming about being an engineer.
Yes, yeah, but you see how it combined. Yes, so you wanted to be a model, then you decided to be an engineer, and now you understand that there is something that actually combines both. Yes, being a model as a scientist, as an engineer, opening the way for other people also to follow, which I think it's a wonderful combination of two. So, yes, everything came to place. Very inspiring story. Now I want to see what were the major challenges in your career, in pursuing your career, and how did you overcome them?
Think I'm still overcoming them because I am from Argentina. It's a low-income country that we are in permanent economic crisis, and this impacts all the places, every human being. But doing research here is can be really challenging. It's like I did a postdoc in Boston, and I decided to be back in my home country. And there are a lot of reasons why one decided to, start and build the career in the home country, regardless of how difficult it can be. And besides, my personal reasons, I also wanted to be here because I feel that if I am building the research of the science from Argentina, I can change some stuff. I can, like connect with other people and have this net of researchers all over Argentina and making this grow and grow and make it better and better. Argentina has a beautiful and good and really high level research. Like we are in a good, really great position to America also. Like that's super something that we are really proud of. But although all of that, the funding are really low, and when it comes from like when your currency is so volatile, so fragile, it's like at this moment, literally, I'm trying to buy tickets to go to a conference that is in Europe. That means a lot of money. Maybe all the budget you have on one bank, and that's something that is really really sad because that restricts us. So I lead a group, and I now considering it like how hard is or like it was hard for me as a student when I was doing my PhD. It was always hard to attend international meetings that are so important for the career of anyone because that's the way you find your next lab. That's the way you find collaborators, and that's so important to have collaborators. Also, moreover, when you are in low income country, because that could be a way of having data sets, or that could be a way of applying your methods on the clinic more easily than in other places. So I know that because I do it all the time. But there is a lot of I think that's the hardest part. Don't have enough resources to make published in some journal that can be really expensive, with fees and go to conferences and and of course when it comes to the BCI, that's our area, really tough to have the devices and the system to have your own BCI lab because they are quite expensive and you have to have the resources to not only acquire them but also maintain them, right? So the way I was able to still I will say jump every barrier I have, and I still have to, because I'm honestly doing, I'm counting every penny to go to this conference I want, that is the BCI meeting. That is one of the most important meetings for our area. So I'm counting every penny to being able to attend for the first time the BCI meeting. I am working this from 10 years, right? So I'm counting every penny to be there. And I am not going to be able to still. But what I wanted to say is that I was able all the time to, I did apply for a lot of like travel grants that different like foundation has. Like there are a grant that can come from like Latin American UNI, or grants that come from International Brain Research Organization, or different grants that actually I won a grant to go to ETH. I did part of my post to my doctoral student there. And that was like, that's why I always feel lucky, because I always have the chance that to successfully apply to those funds and to have the opportunity to attend these amazing places. And did it was because I have the, again, the passion was what was driving me in those moments, and it's driving me like, I want to do this. I want to go to this place. I want to go to this conference. So I was trying to always find a way. So although it's tough and sometimes can be really tiring, yeah, that's the way we are trying to accomplish them.
Yes, you are definitely very passionate about the field, about your work. Without it, I think nothing would be possible, especially in these challenging situations. So, what motivates you? What drives you to persevere and to continue with this research, with what you do, even despite all the challenges?
That's a beautiful question that I do all the time to myself. It's like, why are you doing this? No, no, no. I mean, I do believe that the reason why I'm doing this is because, first, I accept it. I am an nerdy person. I love science. I love to do science. I love to solve problems. That's what I love to do. And in that respect, BCI in particular, for me, is a really beautiful area, beautiful field at which you can combine math with computer science, with rehab, with, of course, biomedical applications and technology, assistive technologies, and all this kind of stuff. And I found, in BCI, when I was already, a master student, that was my thesis was done already in that moment in BCI. I found that that was the place at which everything, was together. That everything was like together. That was the moment in which I find the spark, I would say. And the reason why I keep on working on this is because I need to see that the things we do, because as a general person, I would say I do computational stuff, because that from my field, and also due to the limitation we were talking before, my main contribution in the area are related to what we can do from the artificial intelligence or machine learning side to improve this. So it's a computational side. So I do need, and this is what I want, to see that whatever we do is applied to solve someone and can help to improve someone else's life. That's my dream, to literally see that what we do is being used to help someone in improving their quality of life. And that's why keeping me motivated, because I want to do that. Now I started to lead a BCI group, and now neuroengineering lab, exactly. So we are the Neuro Applied Computational Engineering Lab. And we, of course, are based on building machine learning models. But I am not going to stop until I will see these machine learning solutions being applied in the clinic, in some, rehabilitation scenarios, and to support people and to enhance those people who may have some disabilities. So that's what is keeping me motivated. I want to see that.
Thank you so much, and I wish you all possible success with this. So, Now, for those listeners who might not be very familiar with the field, they're just getting started. Can you explain where exactly in the BCI setup machine learning AIs are coming in? Where do you solve this problem and what type of problem you are trying to solve?
Yeah, that is a really interesting question because when we think about BCI, we should always think about a communication system. So there is an input and there is an output. And the way the system works, the communication, there should be, as every language, there should be some symbols, at which this input can be transformed into these outputs. And the way this is done nowadays is mainly based on machine learning algorithm. That for those who do not know, machine learning is a way or an approach to have an artificial intelligence system. So machine learning is coming in here because my data that are the brain activity that I'm recording in some way could be surface EEG or invasive recordings or can be magnetic whatever you're working on. But my brain activity is the input of my data. And the output is the some cognitive task or some desire of the person or maybe some stimulus that I need to detect. But the BCI the machine learning here is being used in order to transform the activity, the brain activity input to some outputs that can be understood by a computer or an external device. And this is the most fascinating thing for me because machine learning, I go to machine learning conferences. I am also a weirdo there because I work in machine learning for BCI. That's my main topic. And it's so particular the way machine learning are built for BCI because if we are using, in my case, that I'm using electroencephalography, that is most of it can become from the surface or inverse recordings. I do both. But in my case, we are using temporal series, and there are really, can vary a lot from one person to another and can vary a lot to the same person in maybe 2 hours because you are more tired, you have drank more coffee or whatever. So that means a really challenge signal that I have in my input because it's not like a photo that can have similarities. If you take it from different cameras, but you already have the same scene, most probably you can solve it probably easier than when you have different brains with different connections, with different thickness of the hair, for example, right? That can also give some inputs of what we call variability. So machine learning here is so great because it's so ad hoc. We build so ad hoc solutions here, which drives me to what I'm working now. It's we should be able to build machine learning systems that are really robust to the differences we have, adaptive to these changes that we may have, and it's something that we should always consider. This machine learning system should be good, complex, but also light enough if we want them to be run in real life, right? It's not that because I need the output to be given a few milliseconds after the person is thinking about, for example, making a movement, right? Although the BCI is not going to be useful. So that's something, there are some, strings that in all other machine learning problems, maybe they don't have them. So machine learning here is, for me, is like the queen of everything. And I would say queen, not king.
Yes, I love it. I love this comparison. And can you tell a little bit more about the conventional machine learning approaches that are used in BCIs? And what is your contribution? What do you propose to do differently? Or what do you aim to do differently from what exists, at least at this point?
Yeah, so although there are what is called what is thought to be the traditional approaches may change according to which type of signal you are using as input and which is the type of BCI you try to build. But just as a matter of example, because it's what in the area that I work the most. Let's consider here that we have surface EEG activity as input, and the problem is to detect the imagination of some movement that is also from motor imagery. That type of BCI is really helpful for like a rehab application, like when people for some reason have some limbs maybe impaired, and they can use BCI as an alternative tool for like making a more, we'll say, active rehabilitation. So that's a scenario in which I would say where are the traditional approaches. In that scenario in which we want to detect motor imagery, the common steps are: first, we need to extract variable features, which are the information at which the classifier that may say to me the patient wants to move or not their limb, for example. Those features are like commonly being extracted by some spatial filter methods. Spatial filter methods means that we are going to use all the channels, all the recording, and we are going to extract the information that is gathered for all of them at the same time. And these special filter methods are they're really neat. I love them because they are linear models that can be really easy to interpret. So we can have not a black box machine learning model. We can really understand what's going on and the reason why the model may fail, because maybe the patient is not doing the process correctly. And whenever we learned these features that are related to some power of the EEG, that means some frequency that are activated when we think about movements. Whenever we extract them, commonly being used by the common spatial pattern, CSP, in the method, we extract these features, and then we use a linear classifier. Most probably, this is going to be like the gold standard pipeline in order to have inputs at EEG and the motor imagery, like want to move left or right hand as output. So that's like the thing. Something I have been, driving my motivation at the moment is that all the devices, or currently, like everything is more like me at the computer, is indicating the person when have to think about making the movement or not, and if the movement was well done, like or well performed, the task, or imagine the movement, you just say correct or incorrect. That's more or less the type of feedback this system is now giving. This is a really like a corrective feedback, but it's not really a supportive feedback. So I had been working already in the idea of we should have this system to adapt to patient characteristics. We should have systems that can be used not only the first day at which we collect 200 of samples, but also the second day at which we want the system to be more active in the sense of giving feedback, which can be like from the technology point of view and from the rehabilitation point of view. Feedback also means that if the person has their hand impaired, they are going to use an exoskeleton or robotic assisted device that can open and close the hand, right? So those systems at this moment, like the person think about making a movement and they can see the hand being open and closed. And if we think them as rehabilitation systems, these systems are going to be used from one day to another. And what we don't want is that the system have really long calibration times. So we work here, and in the idea of having a small data from session 2 to session 1 in order to support the patient in the process of learning how to command the BCI. And what I'm trying to address now is like, it's not the computer, the one that is just saying you did it correctly or wrongly. Is I want to give support to the patient, like literally, as colleagues say, that put the patient into the loop, like consider the patient part of the loop. Because we need to understand that we are not all every day in the same cognitive and like fatigue or resting state. And we might need our model to adapt to those changes. That is something that is important. But also, if our patient or user of the BCI is still not managing as good as we pretend to. Like, it's not good at commanding the BCI because it's a learning process at everything. We should be able to support the patient in that, the user in that. And the way we should support that is to show them how is that we see the brain activity, how is that the brain, the machine learning system understands that brain activity that was simulated, and why is that we have these outputs. So I want to give more like transparency to the user of how the system is being used. So that will, I believe that is going to motivate more the patients in using this device because he or she will understand more what is going on. Is also having this effect of I did that and I understand how this is being done. It's not that this magic coming on from out of my head. And the way I'm currently working on doing this is like if there is a system that the one was nominated for the BCI Award and you name it before, if there is a system that can provide support and make your your intention to make a movement and convert it into movement, I want to show to the patient how much support the system is giving you. So as when you are a child and you're learning how to ride a bike and you use these small wheels that are added to the original wheels, like there is a moment in which your parents say to you, it's a moment to take this out and you don't have these small wheels attached and you start to ride by yourself. So this is what I wanted to do. It's like support them, give them like the help them in the very beginning, like showing them how much support I'm giving you by this adaptive machine learning solution that we built. But whenever it's time to start to like suppress it and literally encourage them to be them, the one that are provided the stable signal. And this is something I'm thinking is like when you anyone that is making a movement like someone that play tennis, they practice the same movement one and over again. And you have an instructor that say to you, you are doing this wrongly, you are doing this correctly. And this is a process that you do one, you over and you over again. And then when you mastered the movement, it's because you are doing it in the same exactly way from one day to another night. And there is a moment in which you are not really thinking about how to make it. So I want that. So that's what I'm working at this moment. It's like I'm gonna give support, but I'm gonna also show that you are not doing it in the way you did it yesterday. Go there. You remember you do it like this. Go there. So be the same, gesture. So that's the idea.
Thank you so much for this explanation. And now that you already started talking about this idea of your project that was nominated for BCI Award, can you tell how did it develop and more about that project? What was exactly about?
Yeah. So in that project, we aimed at in this context of the BCI for rehab is that we wanted to have a system that can provide feedback to the patient as soon as possible, which means no delay whenever the patient is trying to make a movement or attempt to make a movement, but also avoiding long calibration times because these systems that I was telling in the very beginning that I most probably are built from a special filtering method and then some classifier. These systems may need to be adjusted and retrained. So that means taking more data in the very beginning of the session, retraining the machine learning model. And then after all that is being done, then we can start with the therapy. And that is not the greatest scenario in the rehabilitation idea because we want to use the 45 minutes maybe that we have from the session to give feedback to the patient, which in this case, as I was telling before, will be like the opening and closing of the hand if we are working in upper limb impairment. So with this in mind, we wanted to build something that is retraining-free, as the title was saying in the beginning. So that means is that we are going to have a patient that we are going to record the brain activity in one session in one day. And that will be my data from the machine learning system at which I can build a decoding model, a system that understands anytime a brain recording is as input, if the patient wants or not to make the movement. That's the decoding model. Next day, we are going to use small fraction of the system, maybe 3 or 5 seconds of minutes, nothing, literally, just a bunch of exercises or trials that we ask the patient to do and attempt to make the movement. And the reason why we were able to do so is because we built a machine learning solution at which we can transform the data that is coming from the new session 2, to be closer to the session 1. Because machine learning models are, if you work on like a statistical models, they believe that the distribution of the data is exactly the same that you use for when you train them, when you build them. If for any reason the data has changed, they don't understand it. It's like, this is not the food you gave me, so I don't get it. So in order to make these two guys similarly, we use optimal transports. We use them because we think that what is happening from session 1 to session 2 of the usage of the BCI are like changes in the distribution of the data, in the domains that are called. So we are going to put closer the new domain to look like the old domain. So this is what we did. In order to avoid acquiring long retraining data and also to avoid this recalibration process. And we successfully been able to do so because since we are working in synchrony BCI, it's always the system at which is telling the patient, now you have to think if you want to make the movement. This is what is happening in most rehabilitation scenarios. So we were able to say, okay, this new trial, according to the system, belongs to the class movement. So if the patient was able to make some brain activity, modulation of the brain activity that is being called, if the patient was able to modulate the brain activity accordingly to the task that was indicated, this, matching that I'm trying to do from the new session to the old session should be successful. And this is what the hypothesis and this is what was what we showed in that project, is that we can't successfully use a model that was trained in session 1, in day 1, in a new session that is coming, with the applicability of having better and longer feedback session, because we will be able to provide feedback to the patient as soon as the therapy session starts. Actively, improved the idea of like, if the patient is doing what was indicated to do, this is going to be helpful. And actually, I am a little bit walking ahead, because this is what we're working currently. It's not what we did for that project. But in that project, we were able to have a model at which retraining could be avoided. And we could simulate all these were simulations that we do with real data, but we simulate the scenarios that I'm describing here, in which with only few seconds of data from the new session, you can just have a classifier running online.
Yeah, that is absolutely amazing, and definitely can shorten the time of the session and give time for feedback. So, what is your next step that you are planning to do already after this project? What are your future plans? How are you planning to develop further?
Yeah, so we are currently working in the idea of this system that is based on optimal transport. I didn't say this, but optimal transport is a theoretic from the mathematical side, in which we want to match two things, and I will say things. People may hate me, mathematicians will hate me, but when you want to match two things that looks like similar, but they for some reason they change. So this is what I'm gonna say. That's it. But also optimal transport is such a beautiful, I would say this situation like a mathematical technique. And we believe that optimal transport can give us insights of how well the patient is doing the indicated task that was given by the system. And to put this in context, And I will say it again, BCI for rehab, most probably are synchronous BCIs, at which the system is indicating now you have to think and try to make the movement. Now you have to think and try to make the movement. Now you can rest. Now you have to think and try to make the movement. This is more or less the way. So since the system knows when ideally the patient is trying to make the movement, and since optimal transport understand how to match this brain activity to the brain activity at which the classifier was trained, we are working now on using this optimal transport, this help that we are providing to the patient as a indicator of how good that attempt of making a movement work, which also give us to the need of developing like a more entertained environment, because most of the BCI protocols can be like just an arrow pointed to left and right, and we want to build like a video game in which this activity is being done in a more like a realistic scenario, and in which this trigger that now make the movement or not is not so like obvious. So it's part of the game. So we are working in developing this game, and which we are gonna give rewards, and we are gonna also work in the idea of providing like positive feedback, but with the conditional idea of like I want you to be the one that is doing this and avoid the use of optimal transport in the following step. That's what we wanted to do. And for that, at the moment, we are currently working on the video game. And next, we are gonna make the online. We are gonna record and make this proof in real life application here online. We have a open BCI. I'm naming it because I know you had the podcast from someone from there. We have this is a low cost system that so we are gonna use it. And the idea is to have this system is optimal transport and co-adaptive BCI running online. That's what we are working currently, and we pursue to do in, I would say, the next 2 years, because that takes a long time. So yeah.
I'm very curious to meet with you again on our podcast in 2 years and to see your update and listen about this new system. So that would be amazing. Very good. And right now we see a very rapid development of machine learning approaches, yes, of AIs. How does this development of new approaches and new methods in this area help you to advance your own algorithms and approaches that you're using?
That's a great question. So 2 weeks ago, I was in the most important Latin American meeting in artificial intelligence. It's called KIPU. And that meeting is like our local NeurIPS, in which we have the opportunity to there's a Sunday school spirit, where there are like talks and keynotes and maybe some practicals. So in those places is where I see like everything, the rapid development that we are having in artificial intelligence. ChatGPT is something that everyone is speaking about, right? So all these kind of crazy models that are happening there. And I always listen to them, and everything now in artificial intelligence is literally most of the efforts are like from like natural language processing and computer vision. These are the two, a big field of applications that I can see personally that are driving more of most of the development of artificial intelligence. And when it comes from BCI, from at which we don't have like this crazy amount of data that other applications have, is where we of course are all the time from the BCI. We are all the time for deep learning. We are all the time like learning what have been successful for computer vision. We are all the time like using tools or tricks or way of training the deep learning models that were really helpful for computer vision. I will say something like I love the inspiration that we can have from other areas, but we shouldn't forget that we are working with BCI and the limitation that no limitation that we are not having images. If you are using EG, we are having an EG. Maybe you can have a representation of the EG and a domain like a spectrogram. Those are not images; those are a spectrogram, and we should consider, the knowledge of the domain. So for that, it's like we need to still borrow, of course, the development of others. It is a beautiful and rapid application that we can see, but also think how to apply them in the concept BCI, like apply them with literally like with the respect. It's a technique something. Yeah, it's not like a parameter. So, but I can see that what burdens us to like us as a community, as a BCI community, that although there's a lot of effort, there are a lot of like public data sets at which everyone can use that we use all the time, of course. There is still like there are a few and they are not really diverse. And maybe they are small data sets because small, when we say 10 or 20 patients, and everyone that had big data set know that was an amount of effort. Everyone, as we do know how hard it is to get participants, make up recordings, make them available for everyone. So I know how crazy that effort is. So for that, I do believe that what we need as a community is to share more data. So using the open, data sets and so on, we can do this. And also we need to be aware of that which technique are can be applied of the type of thing that we have. And something that can be maybe someone is not happy with what I'm gonna say. We need to understand, for me, interpretability of the model and deep learning there is a beautiful area of understanding and make them more interpretable. But I do believe we are going to use this in BCI, which we have a medical application most probably. We should be aware of there is any harm if I use this, and if there's any bias in the decoder if I use it with this type of population or this other type of population. That's the thing. It's like there are a lot of deep learning. We actually are working a lot here deep learning for EG, but we need to be aware of the type of data we are working on and the application we are trying to have.
Yeah, thank you for mentioning all those challenges. In your opinion, what is like the main challenge of applying machine learning models for BCI applications?
The big channel is that every brain is different. So the example that I was giving in the very beginning is that a photo of a cat being taken by two different like cell phone cameras is still a cat, right? It can be so in that sense. It's like when we work with EG, that's the signal that I work. So that's all my examples are going to be from that. When we work with EG, it's like the brain recordings from one person to other are really can vary a lot. There are some things that are similar, and that's the reason why we can build like across subject models. But this really depends on the application we are having. It really depends on the task we are trying to solve. There are some tasks that are more easy to solve across patient because you have something that is more stable. But there are others that are really particular for every person. It's like so yeah, it really depends. So that's the first thing. It's like every time I put I put out a cap from the EEG, I have a new head, a new model, that is giving me this EEG, which means that there is a lot of like statistical variability. There's a lot of things that are different from one to another. So the big challenge in order to apply machine learning is how can I find a um, common space of all these brains, of all these recordings. So can be done in different ways. You can have a model that is invariant to these changes. It's like I'm going to learn something that is common and robust, regardless of from where the data is coming. Or we can build something that is adaptive. So, okay, I have this, and I'm going to make it subject specific. I'm going to adapt it to you. I'm going to make it work for you. And if that will depend, of course, if you are trying to use a BCI for like medical application, that will be maybe something that is subject specific, makes more sense. Or if you're using a BCI like for entertainment application, for that, you want something that you can use for everyone, that's something easy to put and some quick setup and blah, blah. So I think that that's the big, big challenge is that variability is huge. And the second one is that whenever you have, I will say, a bad decoding performance, that means my classifier is not good at detecting, for example, the movement imagination or not, we still don't have all the tools to understand if that, that drop down in performance is coming from the model or from the user. It's because the user is not giving me a stable, brain activity. It's because the person is not good still in making the modulation of the brain activity so as, is having some easy to read features from the model. So that's something we are still trying to predict. There are a lot of work trying to predict which are going to be the good users, and I'm opening quotes here because I don't like that. But that there is still, this limitation at which we are working in a blind or in a dark scenario. We never know what's the reason why the model is not working sometimes. We just have to say it is what it is.
Yes, thank you so much. So there is a lot of work that still needs to be done in the area from what I understood. And also, I think something is very important for our listeners that there is so much work to be done on the data that already exists. Of course, we need more data, and it would be good that more data would become accessible. But already you can have data sets, you can analyze the data and come up with the different solutions that would help with future research and with the development of new models and new approaches to the data processing. Yes, how we look at the data. So it's for those people who might start doing something in this field. They don't need necessarily to have a headset, yes, and to record the data. It's a big plus, but you can start already where we are.
Yeah, that's exactly what I did all the time.
Yeah.
So the most of my developments are thanks to beautiful people that have decided to make this recording available for everyone. It was not only until I was in DTH during my PhD studies that I was able to collect data by myself. And now that we have the BCI, open BCI device here. But we are still not, we sometimes do not make new experiments because that is at the moment, maybe we want to devote more time in the machine learning side, and we use available data sets. And that's what we need to do because they are the benchmark. These are the ones that also give to the community the idea of where we are because we are using the same data sets with most probably the same processing and so on. So yes, I mean, for anyone that is listening to this, you don't need to have a complete system to start working BCI. At this moment, you need just a computer.
Yes, and speaking about that, also, I know some people were using MATLAB, and MATLAB also is expensive. It requires licenses. So many people are switching to Python, which I think it's a beautiful alternative. What language, what systems do you use for developing models and for doing this computational work?
Yeah, I remember that maybe 4 years ago, like this question will be a short answer, like I use MATLAB. But now the community and also me has, I think it's more like everyone is using Python. So I use Python and I recommend everyone that if they're starting a new project, or if you use another language, you can use Python. It's similar. If you are familiar to MATLAB, for example, you can find some similarities in Python. And something great about Python is the community. Not only is license free, that is important for example, for me, for my country. It's important to have open source. Like we use Linux, we use Python. Now it's everything that is open source. So, but also because there is a community growing out there. So in particular for magneto and EEG analysis, there is a huge library that is called MNE, and that is a nice way of also introducing yourself. And also, if everyone is using MNE or most, I would say like we are also sure that we are building upon something that was being built in a community that was revised with a lot of people. So my code is also more transparent because of that, because I'm also doing my machine learning that in something that can be based upon something that is already evaluated by my peers and can be used for others because it is easy to be implemented in many Python. Then maybe that will also foster applicability. Also, the community can be much engaged, and it's much easy to contribute to other people projects because we are all using the same language and libraries. So I'm so happy to see this community growing. And when I found M&E, this is a funny fact. I gave a course of BCI in the UBA, Universidad de Buenos Aires, and I prepared all my practicals in MATLAB. That was what everyone was using at that moment. And my students were like, "Oh, I use Python, blah blah blah." Of course, you can use Python. You can use whatever you want. I can read any language of code. If you know how to code, you can then read everything more or less. You have to adjust a little bit. And it was giving that course. I was giving the course. So, and the project, and this is a fun fact, the project of the BCI meeting, the one that was nominated, was a decision that I took, like this is going to be that this is going to be the meeting, this is going to be the project in which I'm going to use Python. And I started a project from scratch using Python and discovering this community M&E and discovering the example and the tutorial you have, which are really, really, beautiful if you're starting in the field also. So encourage people to use and follow that and to contribute.
Yes, absolutely, absolutely. And I'm also giving a course each fall on adaptive neurotechnologies. And we started implementing actually this year, it was 22-23, the practicums on Python. And our students seem to be very interested and happy that they can do it and analyze. So we're going to continue this. So thank you. Thank you for sharing that. And now that you mentioned again your BCI Award project, what do you think helped it to be such a strong project that it was nominated for the BCI Award?
I have the good feeling when I applied at that time because I can see that although this is a methodological project and we didn't have the chance to try it online, no, neither with patient, what makes it really strong is that it's faster the communication between the computer and the patient. It can give, it can help us build a more flexible system. Is It can also provide from the rehabilitation point of view. It can provide feedback to the patient as fast as possible. It doesn't require a lot of computational resources, so it's something light that you can run in any notebook and also in just a few minutes. And online, it's just a few milliseconds. And I believe that there is a novelty that we are introducing a mathematical, formulation into this field, and in a super simple way because the solution is simple. So to be honest, which I think I took the course of optimal transport, and when I was taking the course, I said, oh my god, I can use this in my project, and I came that summer and I wrote the code. That literally that was the way it happened, and I think that the novelty is that we do not need to retrain the classifier. We can build something upon one session that can be only pure for calibration, and everything is just going towards improving the practicability and the usage of the system for rehabilitation without the need from the, and I will say this, if I were the experimenter and the practitioner, and maybe there's no need for you to understand how optimal transport is working because this is something that will be running the computer and will make And this is not something that I like people to think, but we made the magic, you know? So it's really also like something that can be used regardless of how hard the mathematical part be, because as an algorithm, it's really practical. It's really like you just need to have a sample that is coming. So it was as the performance point of view, it was the one giving the best performance from the other competitors that are also in the literature at the time, that are good for trying to match two things together, this idea of optimal transport, but also was the fastest one. So the adaptation was so fast that it can literally be, although people may think this adaptation and all this process and all this crazy computational thing that you're running can give some delays on the output, this model is no adding delay and adding stability to the system. So I think that there are a lot of items that this project is achieving.
Yeah, thank you so much for all these details. And I hope you will continue your submissions for BCI Award and, being among the winners next time around. What would be your suggestions, your advice for those who are considering their submission for BCI Award?
So first, the requirements at which your project is thought to be a good fit for the BCI award, you have them on your website. So be sure that your project is fulfilling most of them, not all of them, but at least most of them. Is that it's important to be clear of how your solution is bringing the gap from this horizon that we are trying to build towards the application we want to have, right? So for me, the most important advice would be like, if you will submit your project, be sure that what you're working on is literally towards the idea of making the usability of the system greater. I think that is what the BCI award is about. And for those, and the cases and my case, that which we most probably do not have super crazy equipment to carry the data, or maybe we are not working in intracranial data, maybe we still do not have patients with intracranial recordings to try some beautiful things, because that's true. I mean, big places has big technology, some patients that can work closer. For those like me, that we can contribute mostly from the machine learning side, we should still keep on submitting our project to that. Because we, as I was saying before, if machine learning is the queen of all of this, we can make our queen, be brighter. And these are the models at which, in the end, can be used in these crazy and beautiful applications that we heard about in the BCI award, like being able to decode the speech for voluntary patient, that was fantastic, or someone that recovered the walking for the spinal stimulation. That thing are crazy. I never thought that was something possible to be done. And I am a biomedical engineer and I work in this area. So that's I would say you should submit, because it's inspiring to be there, and also because it's personally, and I'm super, for me, was such, and I will say this personally, was such a big honor to see my name do in the nomination that time, because it means that, oh my God, we can change the idea of I can change the predicability of BCI by maybe only focusing on the machine learning side. This is also important. It's for the community. So that's it I want to say.
Yeah. Thank you so much that you are emphasizing this point that you don't need to have super crazy equipment, very invasive recordings. There are so many contributions that can be made to the field from different angles and perspective. The most important is that there would be a unique idea, a unique approach that really changes something and solves a very important problem. And as you said today, that there are so many problems that still need to be solved for BCIs to be efficient and in machine learning domains. Yes, very important problems. Yeah. And actually, we are talking about this in one of the BCI, in the initial BCI Award podcast, where we are talking with the jury members of the BCI Award. And there are examples of projects that were done with very simple, with the EEG, for example, but had just this beautiful idea. Yes, and they actually were receiving awards and being nominated. So this is a great way to encourage people to submit their projects for BCI Award. And also for many those who are submitting, it's also important to understand that sometimes it might take a couple of submissions to get to the point where they are nominated or where they receive award. But the submission itself helps to structure their understanding of the project. Yes, they ask you to summarize and to bring the main points about the project. So it helps you actually to have the summary for yourself and think about next steps and improvements that you want to make.
Absolutely. I think that every application we do, although it's not successful, is helpful because we frame our project, we stop a little bit and we think about what we have done and what we want to do. So every submission is great for that. And in the BCI meet, in the BCI anniversary, you are asking also for a video, right? And a video should be uploaded. And that is also a not only there is an abstract that you have to write and be concise and be precise and to describe every item that you are asked for, and regardless what is important for the person. But the video that that is for me was the thing in which you should show what you have built and why this is important. And this is also great because you don't have to explain what a BCI is. You don't have to explain what this is important. You have to go directly to the bone. It's like this is what we want to address, and we did it like this. And there's a great opportunity of talking in the same language without a lot of introduction and motivation and blah blah blah. We just go directly to the bone, and that was for me a fantastic experience. I didn't have to just to talk about all this. I just went to the bone.
Yeah, absolutely. And what would you say was the most important skill for you without which this project wouldn't be possible?
I think that's one skill. So patient. So yeah, I don't believe in that we should be, these super great brain people, intelligent people. It's only the only one that is doing. No, I believe that the skill that we need if we want to pursue the scientific career is to persevere to everything. Because I remember that when I was coding, since it was my first Python project, I have a terrible bad in the code. Everything was working too good to be true. And I remember that always, and this is an advice that everyone should take, never believe in something that is working too good in machine learning, because that's most probably a terrible bug. So yeah, and I was like so disappointed with myself because I was already a postdoc at that moment, and I said, "My God, Victoria, you are still making this type of error. Come on, how come?" And I did punish myself because that's sad, but this is what sometimes we do. And I remember that I had to communicate to my colleague of 28, that these results that I've shown you are wrong. I found a bug when I was when I was cleaning my code, and I yeah, and I just realized that that couldn't be possible. And I was again lucky because they say to me, "You are so brave. You have to be brave to accept that there was an error, and now the results are good, but are not perfectly, are not great, and not crazy great and sexy as they were before." But I remember that I would just about to say, "Oh, maybe Optimal Trump was not a great idea for BCI." I remember I said that because maybe I cannot do that. And I think I came with one of my, also the one of the co-authors, we were like discussing, and we came with this idea of, wait, we should, we can use this. We can use it as during the training process. We can use the level at which the system is telling the patient to do so, and blah blah blah. We wrote a code, and that was the experiment we present to the BCI Award, and that was for me an excellent, and I would say exercise of persistence. Like, yeah, I have a terrible day once, and then I came up with an idea after the crisis.
Yeah, and that's how many things are done. And I think here important is, of course, your persistence, perseverance, and also your transparency, your honesty. Yes, to recognize, yes, this is what it is, and convey it to other people. I think that's really, really important. So,
Yeah, and this is something we should all do. It's like it's fine. We're human beings. We have errors. We just that are wrong. And when we work in this area, something that we should always do is share our code, because if we do that, we are transparent. We are not hiding anything. And if for some reason our debugging process was not correctly being done because we were too tired, because we didn't see it, that could happen, or because we were using a new language that was doing something differently of our old language, programming language was doing before, that was exactly my case, our colleagues may help us. So that's the take home message. Like, yeah, every time that you make it, machine learning solution in every area, make your code publicly available. That will help us.
yes, yes, I absolutely agree. And I was very pleasantly surprised when we submitted one of our papers. I think it was for Nature Neuroscience. We didn't get published there, but we submitted and we were reviewed. And we were asked together with the submission to provide a code and a data sample that it can be used with the code and checked. So I really liked this. I don't know how about other journals. I didn't see anything like that, but maybe no. I think it's a good practice.
Yeah, I do know that the Royal Journal are asking for the code and data availability statement that you have to put it on your manuscript when you make a submission and during the submission too. But I had never heard that you have to upload a demo. That's more or less what the Nature Neuroscience was asking you. Which great to know, because I'm submitting next week to Nature Neuroscience, and I never done that before. So that's a great that's great to know.
Yeah, so I wish you all possible success with the submission. Now, as we are nearing the end of our podcast, I have several questions that I always ask all our podcast guests. One is, how do you see the future of neurotechnologies, of brain computer interfaces? How do you see them in 20, 40, 60, 100 years? You can pick any date. And as you specifically work with the machine learning, maybe you can tell how do you see the use of machine learning approaches of AIs in BCIs in that distant future?
Oh, I do see this. I see that the future of the technology. So now we are in the industry revolution 4, 4.0, right? Maybe there is another revolution in I don't know how many years, but I do see that brain computer interfaces are going to be part of that. I mean, now we are in the area of AI, right? AI is all over us, and every time we do something, there is an AI system that is recommending us to take this road, to see this next movie, or blah, blah, blah. So I believe that BCI is going to be the next way we interact. Not only if we have some disability, but as we interact with a mobile phone, we most probably are going to be interacting by BCI systems. So I do see the Roborock, a future in which we enhance our capabilities sense of BCI. I hope that when we are in that moment, I do believe I do hope that neuroethics are being taken care. All this what may happen if we are directly linking our brain into some kind of device that can be our phone or whatever. I hope the neuroethics be part of all the development, and we are sure that we are not, providing any harm or tool that can be destructive in any sense. But I do believe that this is going to be the way, because typing is so slow, right? I think that if there is something that can think, and there is something that literally writes down what I'm thinking, my grand projects are going to be, reading much faster. But I do see that. I do see that happening. And I also understand that most probably those developments are coming together with the technology developments that we are also seeing in the neurophysiology, like electrodes, invasive electrodes are now like really are way safer, are really safe. And I do see that most probably the future is with invasive electrophysiology and machine learning running in a phone. So I do see that.
Yeah, thank you so much. And we also always talk about doing the impossible. So, what is one thing that you thought as being impossible that you made possible in your career, in your life, and how did you do it?
I never thought that I would be able to, and I would say that I never thought that I would be able to get the position I got. And I never thought that one of my projects would be nominated to the BCI Award. I'm being serious. I know I don't come from, my advisors are not from the BCI area as a thing, like a complete thing, as I am. Like I work this like completely in this moment. So I have to struggle like in a good sense, because they were great. But it was mostly me, the one that was looking at the literature. It was me, the one looking at which are the journals at which we should publish. It was mostly me at which the one that was understanding which are the conferences for the area, and understand. Oh, there is a meeting. Oh, look at this. These are this foundation. Oh, look at this. And it was me, the one that was discovering the work from Argentina in a lab that it was. I think that it was where we were in that moment too, that we were working with this guy. So I never thought myself, knowing the postdoc in the podcast, sorry, talking about this, I never thought myself about that. And the way I did it, it was all the time thinking like how lucky I was. And I think that there was a change of good decisions that were taken with a lot of support of my family and my partner, because that's also true. And everything, if you think about it, or at least in my career, everything was like one change that was linking to another without being, aware of that. So I have a, and I will say I have a desire to have the opportunity of being abroad. So yeah, I asked for that to my advisor. I want to have experience, to have part of my PhD study to make it abroad. He was super helpful. We luckily found a place at which they were happy to having me. I applied to the Senate Cards Near Foundation from Switzerland grant, and I was awarded, and I was able to be in ETH. At that moment, I didn't know how big ETH was. I have to be completely honest. I saw on the very first hands all the beautiful machines from the biomedical engineer that I only read about them in books or photocopies from books when I was in university. And that was my first wow, wow, look at you, Victoria. You are realize where you are. And that was the opening of everything. Then I gave a course in University of Buenos Aires about BCI. That was also super big, important for me. And at that moment, I met someone bring me opportunity, like more or less open the door. And I did my postdoc in Harvard then. So that's something I never thought of in my life. It's like, and everything was like a one thing connected to the other without being consciously being understanding what was going on. And I think the way everything happens was because I have somehow, I am passionate. and I have the chance to have, or the privilege, I will say this because it's not super common, not in my country, like these opportunities. And I have the privilege of having them and taking decisions that were along with my heart. I was doing this because I was feeling this because I am a really career driven. I am a achiever, of course I am. And so, yeah, I will start by thanking my first advisor of everything to everyone that crossed my path because I am here because of a lot of people, right?
Thank you for sharing that. And what would be your advice to our listeners of how to make the impossible possible?
Don't listen to the no because we all the time say no. This is a crazy idea. This makes sense. No, how come? Why should I write to this PI that he or she is so great and impossible? No, do it. Write an email. Everything starts by a great email. If you have an idea and you want to share with someone, just no, do it. Don't listen to the no. The Bruno, as now Disney says. Disney says.
Yes, very good advice, especially when people don't have experience in doing these things. So, probably listening to that is not the most optimal thing that we can do. Thank you so much, Victoria. Can you please tell our listeners where they can find information about the research, about the projects you are doing, and what is the best way to contact you?
So I have a personal website that I try to keep it updated, although I fail every time. So you can find me in as a Google site, Victoria Peterson. That is gonna pop up, and you're gonna see my personal website. If you want to follow me, I mean, I'm really active or try to be active in Twitter. So my handle is bpeterson09. And I also try to keep up a dissemination like an Instagram channel, and that is in Spanish because the idea of that Instagram is to inspire girls and women to pursue scientific careers. So that's literally I just use it for dissemination of what I do, but also what is a life science, how the life science look like. So that is in Spanish. So it's nerda como vos, which means nerd like you. So yeah, you can follow me on those places. And if you want to reach me in my personal website, that is my email address and really responsive. So don't hesitate.
Thank you so much. And we will add all that information for our listeners into the podcast notes. Thank you so much, Victoria, for this absolutely wonderful and insightful and inspiring podcast. Is there anything else you would like to share with our listeners before we end our podcast today?
I'm gonna say that don't think. And coming back to the making possible the impossible. Don't think your your environment literally burdens you because that's true. We have I mean, I am a Latin American woman. English can be a barrier. So there can be like the science is not talking your mother language probably. Most probably you don't have like the economic resources to have the best computer that you can have, or maybe you cannot have these crazy and amazing devices that we were talking along this podcast. But try this thing not to stop you if this is what you want to do. Connect with people. Um, you can connect with people. There is a lot of way of like making, as we were saying, contributing to the field by having a computer and great ideas. Maybe making a mathematical model without the need to have a computer. So I would say like let's try to focus our energy of what we want to do. Let's try to work towards that. And if you are like me in a low income country, we can collaborate, communicate, and try to strengthen our community from here. Because for me, it's important to be here to change the environment for my students and to give them more opportunities. And that will be for everyone, I guess. That is making something.
Thank you so much, Victoria, for this wonderful advice. I wish you all possible success with all your projects, many new wonderful ideas and awards and opportunities for you and your team and people whom you're trying to support and to help, and women in neurotechnologies and engineering. So, my best wishes. And I hope to see you in a couple of years and talk about the new developments and new beautiful things you've accomplished. So thank you so much.
Thank you, Milena. That was so great of having this space to share and to talk about what I feel the passion about. And thank you.
Are you a fearless pioneer in the world of brain-computer interfaces? Do you have an amazing project that's pushing the boundaries of what's possible? Then we want to hear from you. The International BCI Award is one of the biggest and most prestigious awards in the BCI world, and the deadline for submission is September 1st. But don't worry, you don't need a top notch budget or equipment to be a nominee or a winner. All it takes is a great idea and the determination to make the impossible possible. So, submit your project now at bci-award.com or find the link in our podcast notes and join us on this incredible journey to explore the world of BCIs. And make sure to listen to our upcoming BCI Award Neurocareers podcast series for tips and tricks on creating a successful submission. Who knows? You might be the next nominee or winner of the International BCI Award and proudly showcase your nomination on your resume to impress potential employers and establish a successful career in neurotechnologies. But don't stop there. If you're looking for more guidance on succeeding in neurocareers, book a free consultation with me, your podcast host, Dr. K, at the Institute of Neuro Approaches. So, what are you waiting for? Let's make the impossible possible together.